You build this flawless Power BI pilot, like the perfect setup. 20 users, one clean workspace, scheduled refreshes running like absolute clockwork.
Right, the dream scenario.
Exactly. But then you get the green light. You roll it out to 200 users across 6 different departments. You set up daily automated distribution runs, and, well, everything just breaks.
It's a brutal wake-up call.
It really is. Welcome to episode 15 of Dataverse by Ninopol. I'm thrilled to kick off today's deep dive into a massive topic for us today, which is Power BI automation at scale.
Yeah, if you work in enterprise data, you definitely know the scenario you just described. It's too relatable.
Oh, intimately. Suddenly, your reports take 4 agonizing minutes to load, gateways time out during peak morning hours.
Yeah.
And honestly, the absolute worst part is your distribution pipelines silently delivering stale data to executives without a single alarm going off.
Yep. And it's crucial to understand right at the start here, this is not a bug.
Wait, really? It feels like a bug when everything is crashing.
I know, but did you write bad code? Probably not. I mean, this is fundamentally an architecture problem. Pilot environments succeed because they are highly controlled.
Right, they're basically a sandbox.
Exactly. You have small data volumes, patient users who know they're testing a prototype, and constant manual oversight. But production, that is a completely different beast.
Yeah, because in production, that automation suddenly faces concurrent users hitting reports simultaneously. It faces chained refresh cadences across multiple data sets and, tables that organically grow month over month.
Right.
That pristine pilot was just never designed to carry a true production workload.
That's the core issue right there.
Right.
And our mission for this deep dive is to explore the 3 invisible failure clusters that just completely break Power BI at scale.
I love that phrase, invisible failure clusters.
Yeah. We're pulling from our architectural audits and Ninopol's field research to really unpack the specific structural fixes you need to keep a massive data system running. We're moving from the controlled sandbox directly into the invisible walls of production.
So let's talk about the very first wall you hit, which is literally just the sheer volume of the data itself. A team will deploy a standard Power BI Pro license, and they're dealing with a hard, unyielding cap of 1 gigabyte per data set.
Which is tiny.
Right. I mean, in the modern data era, 1 gigabyte is a remarkably tight space.
It's incredibly tight. But, the insidious part isn't the size itself, it's how the limit is enforced.
Oh, because it sneaks up on you.
Exactly. It sneaks up on you because it's completely invisible until the exact moment you breach it. You deploy a sales data set, and on day 1, it's a very manageable, say, 400 megabytes.
Well, it's a breathing room.
Right.
Yeah.
But over 6 months of successful production use, historical data accumulates. It grows to 800 megabytes, then 900, and you get 0 warnings from the system.
Nothing at all.
Nothing. Then, one Tuesday, it hits 1.01 gigabytes, and the refresh just fails.
And the error message doesn't flash a giant red screen telling you to buy more storage either. It throws some cryptic failure code and just leaves you to figure it out.
Which means your automated reporting halts entirely while you scramble for a fix.
What a nightmare.
Yeah. The immediate structural solution usually requires a licensing shift. Moving to premium per capacity dramatically raises those limits.
Okay, so just throw more hardware at it.
Pretty much. Depending on the specific SKU, like a P1 or P3, that limit jumps to 25 or 50 gigabytes and can go all the way up to 400 gigabytes on a P5 tier.
Wow, okay.
Or alternatively, there's premium per user, which gives you up to 100 gigabytes.
But wait, if you cross 10 gigabytes on a premium per user license, the system still fails out unless you manually go into the workspace settings and enable the large semantic model storage format, right?
Yes.
I mean, the engine doesn't just handle it automatically.
No, and that's a vital detail that trips so many people up. You have to explicitly tell the Power BI service to allocate the backend resources for a massive model. If you don't flip that switch, you hit a hard wall at 10 gigs, even though you paid for 100.
Man, that is a trap. Let's look at the default way people bring data into Power BI, which is import mode. Import mode is like loading all your cargo onto a high-speed bullet train. It is incredibly fast because the data is loaded directly into the engine's memory, so your reports are super snappy.
Right, very responsive.
But the train has a strict maximum payload. If you have a 1 gigabyte train, you cannot fit 2 gigabytes of cargo on it.
Exactly.
So, okay, let's unpack this. If space is the primary issue, why not just leave the cargo at the station? Why not switch to direct query, bypass the 1 GB limit entirely, and just ask the database for the numbers live?
Okay, so that is the exact trap intelligent data teams fall into all the time.
Really, it seems like a logical fix.
It seems logical. They hit the storage wall, panic, and switch to direct query. Your data stays in the source database, like Snowflake or SQL Server, and Power BI just asks for it when needed. But in removing the storage ceiling, you instantly create a concurrency ceiling.
Wait, if direct query isn't catching anything in memory, doesn't that mean 50 users clicking a chart simultaneously sends 50 separate SQL queries back to the source server?
Well, it's actually worse than that. Yeah. Every single visual interaction triggers a live query. You click a date filter, that's a query. You highlight a bar chart to cross-filter a map, that's another query.
Oh,
Imagine those 50 users log in on Monday morning. They're interacting with a dashboard that has, say, 6 visuals. That isn't 50 queries, that's 300 simultaneous live queries slamming into your source database, all at the exact same second.
and a standard transactional SQL database is going to immediately choke on that sudden spike of ad hoc analytical volume.
Exactly. The source system responds slowly, the database CPU spikes to 100%, and suddenly users are filing support tickets saying Power BI is broken.
When in reality, the underlying database is just drowning.
Precisely. The architecturally correct fix for this at scale is what we call a composite model. You use import mode, your high-speed train, for static, slow-changing dimension tables like geography or product categories.
Okay, that makes sense.
Then you use direct query only for the massive, fast-moving fact tables like real-time transactions.
But the Power BI engine has to somehow stitch those two completely different query modes together on the fly.
Yeah.
I mean, reconciling the in-memory cache data with the live SQL database responses must require massive compute overhead.
Oh, it requires immense processing power. The Vertipack engine has to build a cohesive result set out of live data and cached data in literally milliseconds.
That's wild.
To run a complex composite model smoothly at enterprise scale, you almost always need premium dedicated capacity. Shared pro infrastructure simply cannot sustain that processing overhead for dozens of concurrent users.
Okay, so we've solved the storage ceiling and the query modes.
Yeah.
But data volume scaling also impacts the clock, specifically scheduled refresh caps.
Yes, the silent killer.
With a standard Pro license, you're strictly allowed 8 scheduled refreshes per data set per day. Premium bumps that to 48. 8 refreshes sounds like plenty if you're thinking about a single isolated dashboard. But in a production environment, you have chain pipelines.
Right. Dataset A finishes its refresh, which triggers dataset B, which then triggers a massive data flow, which finally updates the executive summary report.
And when those chains span across multiple workspaces, they burn through that daily cap of 8 refreshes in a matter of hours.
Easily.
And when it hits the cap, it doesn't always send a blaring siren to the IT team. The automation just quietly stops running.
Yep. So we've solved the storage limits and the refresh caps, the data fits, but now we face a completely new physics problem.
Purchase.
Moving that massive amount of data from your local servers into the cloud without snapping the pipe. We need to talk about the on-premises data gateway.
The bottleneck in the basement. I mean, if your data is a massive surging crowd of people, the gateway is the single door they all have to squeeze through to get to the Power BI service.
And that door is an incredibly vulnerable piece of infrastructure. When teams install the Power BI Data Gateway, they often don't realize it is literally just a single Windows service running on a single virtual machine.
Wait, really?
Yeah.
Just one.
It's just one. Every scheduled refresh, every direct query interaction, every data flow, it all competes for that one machine's CPU and memory.
So think the gateway like a single-lane security checkpoint at an airport. During the pilot phase, at 2 a.m., one passenger rolls up, puts their bag on the belt, and zips through in 10 seconds.
Just full, easy.
Right. But enterprise production is 8 a.m. rush hour. 300 passengers show up at the exact same second. The machine still only takes 10 seconds to scan a bag, but the 300th passenger in line has to wait an incredibly long time just to reach the conveyor belt.
That's a perfect analogy. The machine simply cannot process the parallel requests fast enough. So instead of executing the queries immediately, the gateway starts spooling them into a queue.
Ouch.
A database query that normally takes 2 seconds to run suddenly sits in a queue for 30 seconds before it even begins executing. In the gateway performance logs, this shows up as severely degraded query wait times.
But I'm guessing most BI teams don't actively monitor those logs until the entire system degrades.
You'd be guessing right. Usually not until users are actively complaining.
But wait, if the queue is backed up for 30 seconds or a minute, the downstream pipeline doesn't just wait forever. Doesn't the orchestration tool like Power Automate have a hard timeout window where it just gives up?
It absolutely does, and this is where we see catastrophic silent failures.
Ah, there's that word again.
The HTTP actions in Power Automate, which teams use to orchestrate these refreshes and distribute reports, have a default timeout of exactly 120 seconds. If that gateway queue pushes a refresh past 2 minutes, the HTTP action assumes the connection dropped and times out.
But the downstream export step, the part that actually generates the PDF and emails it to the executives, that still fires, doesn't it?
Yes. The pipeline logic often isn't robust enough to catch the timeout as a hard stop. The downstream step queries the dataset, generates the PDF based on whatever old data is sitting in the Vertipack memory, and the email goes out.
Oh my God.
And because the email successfully sent, the system logs the entire run as a success. No error is raised.
So you are blindly distributing wrong numbers to decision makers, and the system is telling you everything is perfectly green.
Exactly.
How do we fix the gateway queue in these silent timeouts?
You have to implement architectural fail-safes. First, gateway clustering. You don't rely on one virtual machine. You set up multiple gateway nodes behind a load balancer.
Okay, spreading out the load.
Right. Microsoft supports this natively. It distributes the query volume across multiple servers instead of spooling them into one queue. Second, you harden your pipelines. You go into the advanced settings of Power Automate and explicitly increase those HTTP timeouts to PT2H, which is the ISO 8601 string, for a 2-hour timeout limit.
But just extending the timeout isn't enough, right? I mean, you still need to guarantee the data actually refresh before generating that PDF.
Correct. You build in adaptive polling intervals.
How does that work?
Instead of just waiting a set amount of time, the pipeline runs a loop that queries the Power BI REST API to check the dataset's last refresh date metadata. It compares that timestamp against the current time.
Oh, that's smart.
Yeah, the pipeline explicitly verifies the data is new before it ever triggers the export action.
Okay, so the infrastructure is rock solid now. We have clustered gateways, composite models, and 2-hour timeouts with adaptive polling. Then Dave from accounting updates his Windows password, and the entire enterprise architecture flatlines.
And here we go. We've entered our third failure cluster, the human element. We're moving from infrastructure into governance and user management.
Yeah.
In Power BI, workspaces have a limit of 1,000 members, but the real danger is the informal way permissions are handled. These are the silent assassins of automation.
Seriously. In a pilot, a developer usually just uses their own personal credentials to authenticate the gateway and set up the scheduled refreshes. But when that developer leaves the company or, simply rotates their password because of a standard 90-day IT security policy, every single pipeline attached to their identity loses access.
And again, it happens silently. The refresh just fails with a credential error, but it goes way deeper than passwords. Let's say the IT department rolls out an organization-wide multi-factor authentication policy.
Which they should.
Which they absolutely should, but they forget to exclude the Power BI service accounts. Suddenly, your headless automated refreshes start failing because the system is waiting for a service account to tap approve on a smartphone that doesn't actually exist.
That is hilarious but tragic.
Or IT runs an automated license cost sweep, notices a service account hasn't logged in interactively for 30 days, and reassigns its pro license to a new hire. The automation halts instantly.
So how do we implement governance that survives these routine IT updates? I mean, how do we get around the MFA blocks safely?
Through rigorous, non-negotiable conditional access rules in Azure Active Directory, you create dedicated service principal identities, never personal accounts.
Got it.
You work with IT to set up policies that bypass MFA for those specific service accounts, but only if the authentication request originates from a trusted, whitelisted IP address, like your internal gateway server.
So it maintains security without breaking the automation.
Exactly. You also pin their pro licenses, so they are excluded from automated cost sweeps. And finally, you migrate entirely to security group-based access. You assign workspace and dataset permissions to an Active Directory group, not to individual users.
Speaking of individual users and permissions, if we're scaling to 200 users across 6 regional departments, we absolutely need role-level security, or RLS. The East Coast sales team shouldn't be able to see the West Coast sales data.
Of course not.
But if the engine has to evaluate that security context for every single person logging in, doesn't that completely ruin the Vertipack caching mechanism?
Oh, it absolutely shreds the caching efficiency. Normally, if user A runs a query, The engine caches the result in memory. When user B runs the same query, the engine just serves the cached result instantly.
Super fast.
Right. But with a dynamic RLS, the DAX engine has to evaluate the user principal, name the UPN, filter the underlying tables based on that specific identity, and generate a bespoke result. If 200 users log in, the system isn't sharing a cache, it is doing the heavy computational lifting 200 separate times.
Which brings us right back to the CPU bottlenecks we saw with the gateways, just on a different server. How do massive enterprises distribute secure, filtered data without melting their capacity?
When live concurrency is crushing the system, the architectural alternative is utilizing the Power BI REST API for report per recipient rendering.
What does that mean in practice?
Instead of forcing 200 users to log into the live interactive dashboard concurrently, you shift the compute load to an off-peak export process.
Oh, so instead of the server calculating the DAX for 200 live sessions, the API just iterates through the security context one by one, renders a static output for the East Coast team, flattens it into a PDF, emails it, and then moves on to the West Coast team.
Precisely. You apply the row-level security at the point of export. You are systematically distributing static secure outputs directly to their inboxes instead of forcing hundreds of users into a live, compute-heavy environment at 8 a.m. It completely flattens the concurrency spike.
Wow, that is brilliant.
Yeah.
Knowing these pressure points really means we can tell the difference between slapping a Band-Aid on a symptom and pouring a brand new concrete foundation. Some issues absolutely can be addressed with self-service patches.
Sure. If you hit the 1 gigabyte dataset size cap, the immediate patch is upgrading your workspace to premium for more space. If your daily refreshes are timing out because the dataset is too large to process quickly, and your underlying SQL database supports query folding, you can implement incremental refresh.
With incremental refresh, you're pushing the filtering logic back to the SQL server, so Power BI only pulls yesterday's new rows, rather than dropping and reloading 5 years of historical data every single night.
Exactly. If your gateway logs show queuing, you patch it by adding a second node. If your credentials expire, you rotate them. These fixes are real and they work for symptom management.
Nuts.
But the critical insight from Nina Paul's field research is that if you are carrying mission-critical production loads, settings tweaks are no longer enough. The pilot architecture itself is fundamentally flawed for the scale it has reached.
Yeah, you aren't just changing a drop-down menu at that point. You are radically rethinking how data flows through the organization.
When Nina Paul rebuilds enterprise architectures across healthcare, finance, and retail, they shift the paradigm entirely. First, they move away from time-scheduled refreshes and implement event-driven, pipeline-triggered refreshes.
So it's not just running at 3 a.m. and hoping for the best.
No, they set up webhooks from the upstream data warehouse. The Power BI dataset only refreshes when the ETL process signals, hey, the new data has successfully landed.
That eliminates the chaining failures entirely. No more guessing if the database finished its nightly batch job before Power BI starts polling.
It's perfectly synchronized. Second, they implement the REST API distribution layer we discussed, replacing those fragile, timeout-prone Power Automate chains with robust programmatic exports. And third, they radically restructure the workspaces.
In what way?
Instead of organizing workspaces by team, which inevitably leads to massive permission sprawl and RLS headaches, they structure workspaces by business domain.
That makes total sense. It's the difference between building a shed in your backyard and engineering a skyscraper. You have to start with a structured audit of the foundation, or the whole thing is just going to sway in the wind the moment you load it with people.
A structured audit is step one. You cannot fix what you haven't mapped. You have to trace the lineage of every data set, document the gateway node health, and audit every single service account before you start tearing down walls.
Synthesizing everything we've unpacked today. Power BI doesn't just fail randomly at scale. It feels chaotic when you're in the thick of it, but it's not. Dataset limits, blocking your storage, gateway saturation, queuing your queries, and service account fragility, breaking your pipelines. These are entirely predictable failures.
They really are.
They're the simple mathematical consequence of applying pilot infrastructure to massive production workloads. But because they are predictable, they can be designed for upfront.
Yeah, if you are currently in production and hitting these invisible walls, the question is not whether you need to rebuild your architecture. The question is simply how fast you can adapt before a silent timeout or a dropped credential becomes a very loud, very public business problem.
Which brings me to a final thought I want you to mull over as we wrap up today's deep dive. We've spent so much time obsessed with launch day. But what if the true metric of a successful data deployment isn't how incredibly fast the dashboard loads on day one, but how quietly and invisibly it runs on day 100.
I love that perspective.
Look at your own team's setup right now. Think about the automated pipeline scheduled to run tonight. How many silent single points of failure are currently resting entirely on the shoulders of one employee's password or a single 2-minute timeout window?
If you want to start mapping out those vulnerabilities, I highly recommend downloading the Enterprise Power BI Architecture Checklist PDF from the show notes. It covers the gateway clustering and conditional access rules we discussed today.
It's super helpful.
And if your team is already experiencing these silent failures, it is absolutely worth considering a formal Power BI automation audit to map out your specific bottlenecks.
The link for that audit is right there in the description. Thank you for joining us on this deep dive into the Dataverse. We unpacked a massive amount of architecture today, but hopefully those invisible walls are a little more visible now. Until next time, keep your gateways clustered, keep your timeouts long, and we will catch you on the next deep dive.